Hello, I'm Llewellyn. This is my Agile Thought of the Day. So I'm here in South Africa today, and I did all that stuff with lambdas the other day in Java, and I want to start talking about using them in a more fluent way. But before we can have that conversation, we need to talk about extension methods. And I'm going to start with just the generic extension methods and then move on to the implementation in Java. This is already implemented very nicely in stuff like Ruby and C#. So first of all, this entire thing is about readability of code, which arguably everything in the language is, right? Because machine code hasn't really changed since it came out, and everything that we do compiles into machine code. So really, nothing we do gives us the ability to do something we couldn't have done had we just written the machine code in the beginning, except this ability to express things in a much more readable way. All right, so this is really about readability. Let's take a look. For those of you who had HP calculators, you've already heard of reverse Polish notation, but for the rest of us, let's take a look at what this really means. Now, if you're going to put into a calculator this math equation, right, you sort of hit 1 plus 2, then times 3 minus 1 divided by 4, and you'd end up with 2. Sort of an everyday occurrence. And we'd like to take a look at what is it like if we express this in code. So here we are, 1 plus 2 times 3 minus 1 divided by 4. Nice and easy. Right, but unfortunately, 1 is an integer, and we don't have access to the integer class, and so we can't do this. So we have to make functions of our own. So to do that, you're going to do it more like down here. You're going to say n1 equals add 1 and 2, and then take that n and say times 3, and then take that and say minus 1, and then take that and say divide by 4. And that's okay, it's reasonably readable in this place. At the very least, it's executing nice and in order. But then this might be like a little too much space, so you might want to sort of inline all of this, and this is where we get to the weirdness. So here we have now divide by the result of minusing the result of timesing the result of adding 1 and 2, and then that result is now being times by 3, and then minus 1, and then 4. So this is how you normally see sort of this weird reverse Polish notation show up in code. And all extension methods are letting you do is write it in a more fluent method that you'd write if you own the object yourself. Right? If you own the object yourself, there's absolutely no need for extension methods. Extension methods just allow you to add this fluent interface to objects that you do not own. So now that we've talked about what they are, let's take a really quick look at how they work in Java. And so this is a jar file. You can download it. It works in Java 1.6. There's nothing going on weird in the bytecode or anything like that. Although there is a predicate that you have to add the extension thing at the boot level loader. So a little bit of a hack area, but very, very small. I think the entire jar file is less than 3K. So let's take a quick look here again. We have this integer n equals 1. Great. And now we want to say plus 2. We can't do this because it doesn't exist. So we're going to use the extension method, and instead of saying plus, we're going to say use. And then because they're extension methods, I have a tendency to add to the end. So just 2 letters of whatever the last thing is. So math dot plus 2. And this is sort of the thing that puts us into the extension method. So we're going to go back, because this thing gives an integer out, and say times 3. And then let's just move down here to the last line. So this stuff sort of indents properly. And then say minus 1 and divide by 4. Right. And then this should say the expected result is the integer 2. But the actual result is n. Alright, so if everything works, this should work perfectly. But of course, we haven't written any of this yet, so we're going to have to do a little more work. First is this math class. It doesn't exist. Eclipse just working as Eclipse works, nothing added to it at all. Notices that, creates the class. So we're going to create the class, and let's just move this down here and then sort of jump in here a little bit. Alright, so because we want this to be an extension things, we have to say extends extension base. Now this is practically what you're going to do all the time. This is an extendable base for integer. You can just implement the interface, but it just means a little more work has to be done on your side. Alright, so now we come down here, and you can see that there's no plus method. So we're going to hit that. Plus is going to give us an integer. And so now the question is, we're plussing I to what? Well, to the caller. So caller plus I. Great. Getting a little bit further here, we still don't have the times method. This is going to be the same paradigm. And we're going to say caller times I. Come back here, create the method minus. This is going to be caller minus I. And a little bit of keystrokes there. One more time to do the divide by. And this is going to give us caller divided by I. And now if we go here and run this, we should see passing test, because indeed it does equal 2. Great. I should point out, if you do this in Java, there is a little bit. I said that you had to include that up. If you go to your class path, you'll see the extension methods are in the bootstrap entries at the very first entry. Alright. So this is extension methods. It makes your code a lot more readable. Readability, in my opinion, is the most important part of code after the fact that your code actually works.